Hello everyone, welcome to my channel. In this video, we will learn about how to solve the 0 by 1 knapsack problem using the dynamic programming approach. So we have learned about the knapsack problem in the greedy method also. In greedy method, we are placing the profit and weight ratio of an item into the knapsack. That means we are not keeping the entire item into the knapsack. So we are only adding the fractional part of the item into the bag, such that it maximizes the profit. Okay, but the greedy method is not optimal, so that's why we are going to the 0 by 1 knapsack problem. So in this problem, using the dynamic approach, so we are either keeping the item entirely into the bag, or we are not just keeping the item into the bag. That means we are just leaving the empty bag. Okay. So knapsack problem is a particular type of integer program with just one constraint. Each item that can go into the knapsack has a weight and a profit. So now we will compare the knapsack problem with the general problem. In olden days, there was a store. Assume that which contains different types of ornaments which are made up of gold. Let N1, N2, N3 be ornaments and C1, C2, C3 be the cost of the ornaments, and W1, W2, W3 be weight of these ornaments respectively. Now a thief wants to rob ornaments that gives maximum profit. So if he wants to rob the ornaments, he has to either completely keep the ornament into the bag, or he should not place the ornament into the bag. So that we are representing using x equals to 0 or 1. So 0 means we cannot place the ornament into the bag. 1 means we can place the ornament completely in the bag. Okay. So that means we are either or keeping the ornament or not. But in the greedy method, we are adding the fractional part of the item. So that means that item we can divide, but the ornament we can't divide, right? So this problem contains either 0 or 1. In this, we can't place fractional weights in the knapsack. So that's why it is called as a 0-1 knapsack problem. Okay. So here are some of the formulas of the 0 by 1 knapsack problem. So S1I equals to Si minus 1 plus profit of the ith item, comma weight of the ith item. So if suppose single weight moved into the bag, then this formula we will apply. Next, for merging operation, we use this formula Si equals to Si minus 1 plus S1 power I. And initially the bag is empty, the knapsack is empty. So we have to fill the bag such that it maximizes the profit of the bag. Okay. So we will know about this purging rule or dominance rule later. So while doing the problem, so let us solve a problem on 0 by 1 knapsack problem. So this is a problem. So n value equals to 3, that is number of items that we want to move into the knapsack is 3. M equals to 6, that is the maximum capacity of the knapsack, and profits and weights are given here. So profit of 3 items and the weights of the corresponding 3 items. Okay. So initially the bag is empty, that's why we are representing the weight as 0, 0, S0, 0. So here in the formula we are keeping the 0, I equals to 0. So S0, S0 equals to 0, 0. Okay. So now in this formula we are placing the 1 value. Okay. So what happens if we keep the 1 value here? S11 equals to S0 plus, so Pj comma Wj means, so weight of the corresponding profit and weight of the corresponding item. So that is the 1 and 2. S0 plus P1 comma W1, right? So in the next step we will write 0 comma 0 plus, so profit and weight of the first item, 1 comma 2, that equals to 1 comma 2. Okay. So now next we will find the S dash value. So in the merging operation we are having, right, Si equals to Si minus 1 plus S1I. So next we will find out this value. S1 equals to S0 plus S1 power 1. Okay, so we know that S0 equals to 0 comma 0 plus S1 1. So what is the S1 1 value? 1 comma 2. Okay, so that equals to 1 comma 2. Right. So we find out the single weight of the which we want to move into the bag and the merging operations. Okay, so find the S dash equals to S0 plus S1 dash. Okay, so here the S dash means one weight is moved into the bag. So possibilities are, so 0 comma 0 and 1 comma 2. So next, so we place the I equals to 2. In this formula we place I equals to 2. S12 equals to S1 plus. So what is the next I item? Second item, right? We are placing into the bag. We want to place into the bag. So next we will consider that corresponding weights P2 comma W2 and equals to S dash. So what is the S dash value here? Sorry. So here we have to just unite the strings. We should not add the strings. Okay. So plus means concatenation here. So 0 comma 0 comma 1 comma 2. Okay. So S dash plus P2 comma W2. So what is the S dash value? 0 comma 0. So 0 comma 0, 1 comma 2. Now, so what is the profit 2 and weight 2? 2 comma 3. 2 comma 3. So S12 equals to 2 comma 3. So we are adding this set with this values, and so 1 comma 2 plus 2 comma 3 is 3 comma 5. Okay, so this is the second value and first one. So first we have calculated the second item weight here. Now we need to perform the merging operation. So what is the merging operation formula? Si, that is I value is 2. S2 equals to S dash plus S12. So that equals to, so what is the S dash value? So S dash value is 0 comma 0, 1 comma 2. 0 comma 0, 1 comma 2. So here the plus means concatenation in the merging operation. Okay. Next 2 comma 3 and 3 comma 5. So we are adding this, we are uniting these two values S dash and S12 and 3 comma 5. Okay. So this is the second one. Now let us consider the next item. So what is the next item? Third item. So S13 equals to S2 plus P3 W3. Okay. So by applying this formula we get this value. Okay. S1I. So ith item is third item. So S2 plus P3 comma W3. So that equals to, what is the S2 value here? This one, right? So 0 comma 0, 1 comma 2, 2 comma 3, 3 comma 5. So we are adding the profit and weight of the third item, that is 5 comma 4. So if you add this value with this, so we get the 5 comma 4, 6 comma 6, 7 comma 7 and 8 comma 9. So this is the third one. Okay, so now we need to perform the merging operation. So for merging operation we have S3 equals to, so what is the S3 value here? So for merging operation we have to apply the formula. So Si minus 1, that is S2 plus S13, that equals to, so what is the S2 value here? So 0, 0, 1, 2, 2, 3, 3, 5. So similarly here we are writing these values. So 0, 0, 1, 2, 2, 3 and 3, 5 plus, so what is the S13 value? So this is the S13 value, right? So we'll add these values. So we are going to concatenate these values, not add. 6, 6, 7, 7 and 8, 9. Okay. So in this manner we are going to add the value. So here if you observe, so we are going to unite these two values, that is S3 equals to, so 0, 0. So we are going just to unite this, apply the union operation for these two sets. 1, 2, 2, 3, 3, 5, 5, 4, 6, 6, 7, 7 and 8, 9. But here if you observe, the 7, 7 and 8, 9 are cancelled. So we are going to cancel these two values because they are exceeding the weights are greater than the bag capacity. So here the weights are greater than the bag capacity. So that's why we are going to remove these two sets from the given set S3 value. So if you cancel these two, so then the set is only 6, 6. Okay. 0, 0, 1, 2, 2, 3, 3, 5, 5, 4 and 6, 6. So this is the S3 value. Okay. So now if you observe the 3, 5 and 5, 4 here. So here we are going to know about the purging rule. So what is the purging rule? So purging rule or dominance rule means if one of the Si minus 1 and S1I has a pair, so Pj, Wj, and other has a pair Pk, Wk and Pj less than or equals to Pk, while Wj greater than or equals to Wk, then the pair is discarded. So then the pair Pj, Wj is discarded. If suppose the profit and, so the profits are in the ascending order, then it's okay. But if the weights are in descending order, then we need to remove the, so the first set, that is the Pj, Wj value. So we have to remove this pair, the first pair, from the given set. So if you observe here, so here all the values in the given set are in the ascending order. So 0, 0, 1, it is in ascending order, 0, 2 ascending order. So that means the profit J and Wj, Pj, Wj and Pk, Wk. So these are in ascending order. So it is okay. Next we will check these two, 1, 2 and 2, 3. So these two are in ascending order. So Pj is less than Pk and here Wj is less than the Wk. Okay. So here also if you check, so this will also satisfy the purging rule. Sorry, it is normally correct. So if you observe these two things, so Pj is less than or equals to 5, it is correct, and 5 is greater than or equals to 4. So that's why here the dominance rule will happen. Okay, so it should not dominate the previous values. So that's why we are going to remove the, which pair we are going to remove here? So Pj, Wj. So we have to remove this one from the given set. 0, 0, 1, 2, 2, 3. So we are removing this one. So 5, 4 and 6, 6. So if you check these two values, whether there is a dominance, it is satisfying the dominance rule or not. So 2 is less than 5. So it is okay. and 3 is also less than 4, so it is okay. So we can simply check in whether the given sets are in ascending order or not. Instead of checking this dominance rule, so we can check whether these are in the ascending order or not, the adjacent pairs are in ascending order or not. Okay, so this satisfies the dominance rule. Okay, so it is the okay. So we have checked the dominance rule, right? So after that one, we have to check whether the we have to select the maximum profit and weight pair. So here the maximum profit and weight pair is 6, 6. So we need to check the previous sets whether it is available in the S2 or not. So here in S3 the maximum profit is 6, 6. So we have to check whether it is available in the S2 or not. So we will check that one. So based on the given condition. So if Py, Wi belongs to Sn, that means this weight belongs to the S3 value, and Pi, Wi doesn't belongs to Sn minus 1. That means if this same pair 6, 6 doesn't belong to Sn minus 1, that means S2. Okay, S3, right? Sn means here S3 and Sn minus 1 means S2. If 6, 6 doesn't belong to Sn minus 1, then Xn equals to 1 or otherwise Xn equals to 0. Okay, so here the 6, 6 belongs to S3, and so we will check whether it is available in the S2 or not. So we will check. So here it is not available in the, so it is not available in the S2. Okay, so 6, 6 is doesn't belongs to S2. So then what will happen here? X3 is 1. So here this condition is satisfied, right? That's why Xn equals to 1. Or else that means if 6, 6 is also there available in S2, then Xn will become 0. So here this here what will happen? X3 will become 1. Okay, so based on this condition. Okay, so now we will leave the X3, the third item, right? So because it is 1. So now next we will check the remaining items, that is 2 and 1. So we will compare 2 and 1. So we will consider the 2 value. So what is the maximum value in the 2? So okay, no need. So it is we have to find the maximum value only for the S3 value, not for the S2 value. So here we are performing the subtraction of the 6, 6 minus 5, 4. Okay, because since the 6, 6 is there in the S3, so X3 equals to 1, it is satisfied. So now we will have to remove this one. So that's why we are checking it with the 5, 4. So we are subtracting it from the 5, 4. So 6, 6 minus 5, 4. So that equals to 1, 2, which belongs to S2. Okay, so 1, 2 is there in the S2, right? So now we need to check whether 1, 2 is there available in the S1 or not. Okay, so where is the S1? So here the S1 value. So 0, 0, 1, 2. So 1, 2 is also available in the S1. So it is available in both S2 and S1. So now, so we'll check the condition here. So based on the condition, so the S2 value here, X2 will become 0, right? So it is not satisfying this condition, right? So it will become 0. So now X2 will become 0. Now we will check the remaining two things, that is the S1 and S0. So we have finished the S2 and S3. So X3 equals to 1 means we can place the third item into the bag, and X2 equals to 0 means we should not place the second item into the bag. So since it is not satisfying this condition, so we are taking the 1, 2 and we are checking whether the 1, 2 is available in both S1 and S0 or not. Okay, so in the S1, so 1, 2 is available, and in the S0, so it is not available, right? So that means it is satisfying this condition, given condition. Okay, so 1, 2 belongs to S dash, and 1, 2 doesn't belong to S0. So that's why x1 will become 1. That means we can place the item 1 also into the bag.